What are vectors? Basically, there are three different perspectives to look at vector. First is the computer science student's perspective. What he thinks is that vector is just an ordered list of numbers. These square bracket represents that this is a list, and the numbers inside it are called as elements. Now, note here, the word ordered matters here because if we take another list over here with the same elements as this list, but I change the arrangement of those. For example, in that list, first element would be 19, second would be 2, 100, and 1. Then this list and our original list would not be considered as same vectors. Now, as per a physics student's perspective, vector is an arrow that is pointing in space and it has two definite things. First is a particular length, it has a fixed length, and second is a specific direction in which it is pointing. Now comes the mathematician's perspective. As per him, a vector is anything that obeys two fundamental operations, that is, vector addition and vector multiplication. Now, whenever I tell you the term vector, I would like you to imagine a 2D coordinate system. Yeah, this is called the x axis and this is called the y axis. These both axes form the 2D coordinate system. Here, this point is known as the origin because it is having the coordinates 0, 0. Now, each and every factor that we will be talking about would have its tail fixed on this origin. Now, you must be wondering, how do I define vectors numerically? For example, a vector can be this also, a vector can be this. How do I define it numerically? So, as we discussed right now, just take the vector and fix its tail to the origin, and then we can define the vector numerically. Let us assume that this is 1, this is 2, this is 3, and this is 4 on the x-axis. And here on the y-axis, this is 1, -1, -2, -3, and -4. Now, if we try to join these dots, it joins here. So, the vector would be, first we will be writing the x coordinate, that is 4, and then we will be writing the y coordinate, that is -4. So, this vector can be represented as 4 minus 4. Now, this vector is known as a 2D vector. Why? Because it has two dimensions. First is the x dimension, and second is the y dimension. Here is another example of 2D vector. Can you guess the coordinates of this vector? Or can you define this vector numerically? No. Now, let us talk about 3D vectors. Vectors which have three dimensions are known as 3D vector. For example, in this case, we are having x-axis, y-axis, and a z-axis. So this forms a 3D space. How do we define vectors numerically or geometrically in 3D space? Here is how. For example, consider a vector 2 who is having the coordinates 2, 1, and 3. Here, 2 represents the x-axis. So let us mark 2 point towards the x-axis. Now, this 1 represents the y-axis. So let us move 1 step towards the y-axis, which would be here. And then this 3 represents the z-axis. Let us move 3 steps to the upward direction, that is the z-axis. And this is the final point where we reach. So we can draw a vector here at this point. Okay, I'm sorry. I have to make sure that the arrow is pointing towards this direction. Yes. This is the final vector that we get. So for a better visual understanding of what I just explained over here, here is the image. This is the x-axis, this is the y-axis, and this is the z-axis. Here, x is having 2, so this is the 2, 1 for y, and 3 for z. Now comes vector addition. If I ask you to add two numbers, for example, 2 and 5, what would you do? You'll simply add them as 7, right? But if I ask you that how would it look like in a number line, which is having, for example, this is 0, 1, 2, 3, 4, 5, 6, 7. Here this is 2 and here this is 7. What we're actually doing is that first you are moving two steps to the direction in which 2 is there, and then you're moving 5 steps to the direction where 7 is there. This same rule you have to apply in 2D vectors as well. Here, for example, there is this v vector which is pointing in this direction and w vector which is having this direction. So now, whenever I tell you to add these two vectors, what you will think based on the example just I explained you? First, I'll move in this direction of the v, and then I'll move to the direction in which w is there, because w is moving in this direction, and I stopped at this point. So I'll continue my journey from this point in the direction where the w vector is pointing, right? This is exactly what vector addition is. Here, I'll show you. See, I moved this w at the tip of the v vector, and then I just mark the point where my journey ends, and then I draw a vector to that point. This would be the addition of these two vectors. Now, how do you solve this thing numerically? Numerically solving this is very easy. For example, the coordinates of the first vector is this. Just a minute. Yeah, is this. The coordinates of the second vector is this. Then you have to simply add the coordinates first of the x-axis and then of the y-axis. For example, in this case, what I'll do is that 1 plus 3, which would be 4, and then 2 plus minus 1, which would be 1.